Hello everyone, hope you are all doing great. Today let's understand a topic which you are all waiting for, sampling and non-sampling errors. Let's start with sampling error. As the name suggests, sampling error arises when a sample is not representative of the population, or it is caused by observing a sample instead of whole population. To keep it very simple, the error arises whenever the sample we select for study doesn't represent population completely. Let's understand this with an example. Just imagine I have a set of elements to be studied. So I call this set of elements as population. And we know it very well that it is practically not possible to study this population as a whole or to study each and every element of this population. So what we do is we select a subset of this population, a small group of this population which represents the characteristics of population. So this subset or a small group which is picked out of this population represents characteristics of this population. So what we do is we study this sample and we generalize the results to population. So this subset is called sample. Due to restricted resources, we have to study the sample and generalize the result for whole population. In most of the cases, it is very difficult or not possible to study each and every element of population. So what we do is we generally study the sample and generalize the result to population as a whole. Other day I was asked a question, sir, does it give us a complete picture? This sample, is it representing the population perfectly? The answer is no. The sample can never represent the population perfectly. So this difference in representation itself is called sampling error. I repeat, when we know that the sample can never represent the population perfectly, this difference in representation is called sampling error. Let me elaborate with a continued example. Let's assume this population consists of 200 students. This population consists of 200 students. And now we want to study and understand the average height of these 200 students, or we want to understand and enumerate the average height of this population. So what we do is we pick up a sample of 20 students. We pick up a sample of 20 students. Now let's assume we have collected information from each and every student, that is, we have measured the height of a set of 200 students. So what we have done is we have added the height of 200 students and divided it by 200. So what we get is we get the population mean. So let's imagine we have measured the height of all these 200 students and we have arrived at the average height. That is, we have measured the heights of all 200 students, added them up, divided it by 200 in order to arrive the average height of these 200 students. Since these 200 students represent population, this average is called population mean. This average is called population mean, which is also called population parameter. And let's imagine it turns out to be around 165 centimeters. And now what I do is I measure the height for these 20 students whom we have selected as sample and arrive at the average of these 20 students. Since these 20 students represent sample, the average height here is called sample mean or sample statistic. Let's imagine it turns out to be around 168 centimeters. So what we have done is we have measured the height of 200 students and arrived at an average, which is called population mean or population parameter in statistical words. And also we have measured the height of these 20 students whom we had selected as sample for study, and we had called the average as sample mean or sample statistic in statistics language. So the population mean turned out to be 165 centimeters and the sample mean turned out to be 168 centimeters. Now this difference of 3 centimeters or the difference between sample statistic and population parameter or the difference between sample mean and population mean is called sampling error. Alright, so sampling error is nothing but sample mean minus population mean, or it can also be calculated in terms of sample statistics minus population parameter. Here I am getting sampling error or the difference just because this sample which I have selected doesn't represent population perfectly, and this holds good in most of the cases where the sample we select doesn't represent population perfectly. Almost all cases it holds good. Now the next question is how to reduce sampling error. How can we reduce this difference in order to arrive at a particular accurate result? So the sampling error can be usually reduced by two ways. First is by increasing the sample size. So here instead of this 20 students, if I increase it to around 40 or 60 students, probably this difference would be reduced. And mind it, the difference probably would never be zero until I enumerate the result of all 200 students. Until I don't take up the result of all 200 students as my sample, the sampling error would never be zero. So if I increase this sample size of 20 to 40 or probably 60 or 80 or 100, the difference would reduce. The difference would reduce, but it can never be zero until I consider the whole population for the study. And second way is by selecting better representative sample. Second way of reducing sampling error is by selecting better representative sample. Here probably what I have done is I have considered the taller guys in class so that the sample mean is turning out to be 168 centimeter compared to population mean of 165 centimeter. Probably if I take a better judgment and select students of different height ranges, this error can be reduced. Or probably if I only select the shorter guys, the sample mean could have been around 155 centimeters. So we have a lot of difference at that moment. So here the sampling error also can be reduced by selecting better representative sample. So these are the characteristics. Sampling error can be zero only in case of complete enumeration. Whenever we study the population only, then only the sampling error can be zero. And sampling error is inherent and unavoidable. We cannot avoid sampling error, but we can reduce it either by increasing the sample size or by selecting the best representative. So this is all about sampling error. So let's also look at what is non-sampling error. Sampling error is usually observed in the process of selecting sample for study, but non-sampling error is something which follows that. Non-sampling error is usually observed at the stages of data collection and processing of it. Just like sampling error, even non-sampling error is something which is difficult to be eradicated, and non-sampling error is not in the hands of the researcher. That's something which cannot be controlled by researcher. Non-sampling error is observed due to multiple reasons, like first one is respondents may not quote the right information. This has been observed in each and every research. Whenever it so happens, most of the time a respondent is forced to give answers to a particular set of questions. So whenever he finds he don't have any benefits out of answering the questions, he would not be quoting the right information. Even we do this most of the times whenever we are forced to give a response regarding a survey. What we do is we somehow try to avoid it or finish it as soon as possible instead of trying to take it very seriously and quoting right information. And the next point is it also happens while transferring data from questionnaire to spreadsheets. Thanks to online modes of doing survey, this error can be reduced. But in the initial days, most of the times when we were collecting information through forms, it was very difficult to transfer the same data from questionnaire to the actual spreadsheet where the calculation or analysis takes part. Whenever we are transferring huge data, probably the answers or responses for 25 to 30 questions for around 1,000 of respondents, the error in transferring the data is bound to be observed. Next is while coding, tabulation and computation. Here the error is been observed in the stage of processing of data. That may be due to various reasons like inadequate scrutiny of data or probably publishing the tabulated results wrongly or probably selecting the ineffective graphs where the end result cannot be communicated or the data is not perfectly set for analysis. Next reason would be population not being clearly defined. It's very important to understand and identify what our population is. If we don't design the population properly, then we may not be able to select the proper sampling frame as well as the right sample. Next reason would be missing selected respondent. This can also be called as non-response error, where we have selected certain elements from which we are expected to collect the information, but somehow or due to some reasons the respondent avoids giving responses or he refuses or probably he becomes absconding at the day of data collection. So even this can lead to non-sampling error. And the final point is sampling frame error. Let me explain this with an example. Let's assume the population I choose to study has 1000 people, and among that 1000 people, 600 are men and 400 are women. That is, the population I have selected has a ratio of 6 men is to 4 women. Six men is to 4 women. Now, when I select a sample size of 100, even my sample size of 100 has to have 60 men and 40 women. If I have my sample of 100 people under study, then my sample should have 60 men and 40 women. Why is this important? Because this actually gives, or it tries to give, a better representation of sample with population. If it doesn't happen, then the results we get may not be accurate, or the information we collect may not be apt for study. So this is sampling frame error. Now let's look at an interesting characteristics of non-sampling error. Non-sampling error is always observed with both sample survey and census. In case if we select the census for study, or if we collect information through census method, we can avoid sampling error. But non-sampling error exists both with samples as well as the census method of studying. So non-sampling error is something which cannot be zero, which can never. So that's all from me about sampling and non-sampling error. Have a nice day.